Today, we will learn what is special about robot vacuums. And let's find out what is the chemistry behind the eyes of a robot vacuum. Good day everyone, I'm Ferdy Nicolas Valera and this is Chemistry for Engineering.
Upon answering that question, let's dive into these informations to learn more about this topic. Robot vacuum cleaners use sensor as its eyes. The most commonly used as its sensor is the LiDAR sensor or light detecting and ranging sensor. The LiDAR sensor uses the pulse and return of laser to gather information, which help the robot vacuum cleaner to see its obstacles. Pulse refers to a burst of light energy that is emitted by the LiDAR's laser diode, and return is the reflection of light which catches by the APD or Avalanche photodiode of a LiDAR sensor. Imagine this object as light energy. My right hand throws the light and my left hand catches the light after it bounces back. My right hand acts as the laser diode, while my left hand acts as the avalanche photodiode. APD or avalanche photodiode is a diode in reverse bias that turns the light energy into electricity signals. We all know that electricity is the flow of free electrons between atoms. In a diode, we use semiconductor silicon that dope with other materials like germanium, phosphorus, and aluminum to change the electrical property. These form the P-type and N-type of a diode, which we will tackle later. First, we want to know how silicon do its job in a diode. So we have here the silicon atoms. Each atom wants 8 electrons in its valence shell, but it only has 4. So they share electron with their neighboring atom to complete 8 electrons they desire. It is called covalent bonding. We dope the other materials such as phosphorus to create the N-type region. Phosphorus have 5 electrons, while silicons have already 4, and they only need 8. So the excess electron freely moves around. On the other hand, we dope the silicons with aluminum to create the P-type region. Aluminum only have 3 electrons to add in silicon, which have 4 electrons, so they did not get the desired 8 electrons in their valence shell. The missing electrons in their valence shell creates a hole that 3 electrons can occupy. Now, we have 2 doped pieces of silicon, one with too many electrons and other one with not enough electrons. This creates the depletion region in the center of a diode. In this region, some of the excess electrons from the N-type move over to occupy the holes in the P-type. This will form a barrier with build-up of electrons and holes on the opposite sides. Electrons are negatively charged and the holes are considered to be positively charged. Therefore, the build-up causes slightly positive charge and slightly negative charge region. Silicon as a semiconductor have topmost level 2 bands, the conduction and valence band. Valence band is filled with electrons while conduction band is where the energized electrons go, which produce current or electricity. In depletion region of our APD, the valence band filled with electrons, but there is no energized electron to move in conduction band to produce electricity. Well, the photons, the particles of light, have enough energy to push electrons from valence band to conduction band. So if APD receives photons, it produces electricity which acts as signal for the device. Now we know why this robot can see an obstacle on its way of cleaning. How amazing our technology today! We learned from a simple silicon that doped with special materials and light particles, and a little bit of magic of physics and chemistry, we can give a robot an eye. Again, I'm Ferdy Nicolas Valera, and this is Chem for Engineering.